Hello, my name is Azharul Harif bin Kamar Zaman with matrix number B0921100184. I am from Bmma 1/1. Today, I will explain to you about static shielding mounted cassette analysis. First, I will describe the introduction and objectives of our study. In this assignment, the main goal is to design a FBD for an shielding-mounted cassette. The general description of shielding-mounted cassette is shielding cassettes are a type of split aircon system, which means they consist of two units. It's easy to recognize a shielding cassette aircon because its indoor unit is installed on the shielding. We need to analyze and identify the equation of equilibrium and force acting on the structure. And our objective is, first, to analyze the free body diagram on shielding mounted cassette structure. Second, to identify the equation of equilibrium of shielding mounted cassette. And the last one is to find and discuss about all force acting on the structure. Why we need to sketch and analyze the free body diagrams? Because free body diagrams are used to visualize forces and moments applied to a body and to calculate the reaction in mechanism problem. These diagrams are frequently used both to determine the loading of individual structural and components and to calculate internal forces within a structure. That's why we sketch and analyze the free body diagram. Why is equilibrium is important in static? Because equilibrium states a point in which the system state will remain naturally as long as there are no disturbance. In mechanical systems, this means that at the states, the equivalent force acting on any part of the system is zero. These states are important for statics because any statics problem exists in a system that is in equilibrium. This allows you to assume the condition of equilibrium are met, zero equivalent forces, which allow for calculating inner force in the system.
Hi, my name is Navinesh from Bmma 2/1. My metric number is B0921100394. Now I'm going to talk about a system of the structure and assumption of ceiling mounted cassette system. The system of the structure is called split aircon system. The reason we call it split aircon system is because we have four direction of airflow. Basically, this ceiling mounted cassette is way cooler than normal air conditioner. Next is about the assumption. The ceiling mounted cassette is more suitable for larger areas. This is because, as I mentioned earlier, it has four direction of airflow and it's way cooler, so it cools large area faster. The ceiling mounted cassette is easy to install and does not require ductwork. Ceiling mounted cassette unit are mounted in the ceiling and are best suited to the floating or suspended ceiling where there is sufficient space to accommodate it. Finally, the harder the aircon works, the more energy it requires. This is one of its disadvantage as it requires more energy to work.
Hello, my name is Harwin Naidu, son of Arjun Naidu. My metric card number is B0921100020. So today I'm going to explain about the free body diagram. From pole A to pole C, the height is 2.5 meters. And from pole C to point E, from point C to point D is 0.629 meter, while from point D to point A is 0.267 meters. The angle of the point D is 45 degrees. Meanwhile, the angle of point C is 90 degrees and point B is 45 degrees. So the weight is 16 kilograms, and to convert into Newton, we will be using the W weight equals to mg formula, which is equals to 16 kilograms times 9.81 Newton. So the total weight of this pole is 156.96 Newton. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafshan bin Muhammad Nordin from Group 11. I will explain about the calculation. First of all, to find the reaction force at point C, which is Cx, we use moment method between point C and E. First, we take the force at the point E and time with distance C to E, which is 0.896, and plus with 2.5 cx. Then we move negative 140.64 to the right side and we divide it with 2.5. From that, we will get the cx value, which is 56.25. After that, to find ax, we use summation of fx equal to 0. Force at axis contain as and cx, that if we minus both of them, we'll get 0. So to find ax, we substitute the cx value in the ax minus cx equal to 0 equation and move negative 56.25 to get ax value. Then the reacting force at y-axis are ay and force at E. Because of the object is in equilibrium state, so the total force at that area is equal to 0. So we can find ay value by substitute force at the point E in the ay minus E equal to 0 equation and move the negative 156.96 to the right and we'll get the ay value. To find force at support bar, we also use moment method equal to 0, which is we take force at point E and time with the distance 0.896 and minus with fd sine 45 times with 0.629 equal to 0, and we will get negative 140.64 minus 0.445 fd equal to 0. Then we move 140.64 to the right, then we divide it with negative 0.445 and we will get the fd value equal to negative 360.21 Newton. Second, to find cy value, we use summation fy equal to 0 by plus force at point E with 316.21 sine 45 degree. So the result we will get is 380.55 Newton. After that, we use equation of equilibrium to find force F2 and F4. First, we plus F2 times distance 0.6477 with F4 times 0.6477 and minus it with 156.96 times 0.3239 equal to 0. Then we factorize 0.6477 times F2 plus F4 equal to 15.84 Newton meter. After that, we use 15.84 divided by 0.6477 and we will get the value F2 plus F4 equal to 17.49 Newton. We assume that F1, F2, F3 and F4 is sharing the same value. So we take the value of F2 plus F4 divided by 2 to get the value of one force only, which is 39.25 Newton. So that the value of F1, F2, F3 and F4 equal to 39.25 Newton. That's all from me. Thank you.